Okay, today is a continuation of yesterday's lesson, which was identifying key features of a parabola. Mini lesson number 3. Above this, please write down mini lesson number 3. The learning objective is to identify increasing and decreasing intervals. Now there's a couple facts you need to know about identifying increasing and decreasing intervals. The first one is increasing and decreasing intervals will always be described in terms of x values. And the second is your answer will always be written with parentheses. And I'll describe why in a little bit. So here's our very first function. We're looking at a parabola that opens upwards. And I want you to read this just like you read a book from left to right. So think about yourself as like riding a bicycle. So we're going to start here and we're going to go from left to right. When you start here, as you begin to go to the right, you'd be bicycling downhill. Going downhill is described as decreasing. So I'm going to use red to show that. So you're decreasing, you're decreasing, you're decreasing. And then you get to the very bottom of the hill, and it's like you're neutral there. You're not going up or down. But as soon as you start to go forward, you now are going uphill. So on your bicycle, you're riding downhill, downhill, downhill. You get to the very lowest point, and you're flat. You're neutral. You're not going up or down, and then you begin going uphill. So the first thing is, by the way, we consider this to be a minimum value because the vertex is the very lowest point of the graph. And it has the ordered pair of +1, -1. And now we will identify increasing and decreasing. So it's only done in terms of x values. So it starts at an x value of 1, and it continues as it moves to the right to increase infinitely. So I put a parenthesis around the right-hand side, which has the symbol for it moves to the positive infinity, to positive side. But on the left-hand side, most of us are used to putting a bracket. We are going to actually include a parenthesis here. And the reason for it is at the value of x equals 1, we don't consider it to be increasing. It's neutral. For decreasing, it comes from the far left, and it continues to decrease until it gets to an x value of 1. Again, parentheses, because we cannot touch negative infinity. And at +1, we don't consider it to be decreasing. It is neutral. Okay, please go to mini lesson 1. It's on the second level, a problem we did yesterday. We've already completed the vertex, domain, and range. Let's do increasing and decreasing. Okay, so for this problem, we read it from left to right. So from left to right, I am going down, 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 down. Oh, I stop at this point. There's your neutral point. Again, from left to right, and now you begin to increase. So I am decreasing, coming from the far left, decreasing. And you continue to decrease until you get to what x value? An x value of -5. Parentheses around both portions. We cannot touch negative infinity, and -5 is like a neutral point. You're not going up or down. You're not increasing or decreasing. Then we start to increase at -5, and we continue to increase as we move to the right. Help me out right now. Thumbs up, middle, or down based on your understanding. Okay, with your partner, you are now going to attempt this problem. Even though it doesn't say it, let's add to it. Please write increase and decrease. I'm going to give you 30 seconds to do it. When you're done, and only when you're done, please glance up at the board to see if your answer is correct. Begin talking to your partner. let's go over this. Thank you for working well with your partner. From left to right, always reading a graph, left to right. So you're riding your bicycle, are you going uphill or downhill right now? You're going uphill, which is increasing. In terms of x values, you're coming from the far left. You continue to increase until you get to this value, which I believe, does it look like negative 2? Yeah. Remember, negative 2 is neutral. You're not going down or up. Then decreasing starts after negative 2, and it continues as you go to the right. So a common mistake I see is students want to attach a negative sign here. And I can see where they're thinking, but it's going down, miss. Remember, in terms of increasing and decreasing, we only talk about x values. So this is decreasing as we go to the right. And when we describe going to the right, it is a positive infinity. Okay, before I move on to mini lesson number 4, I do want to talk about end behavior because students struggled with that. Let's talk about end behavior right here. So with your partner, let's set it up. Okay, this is going to be a 15 seconds. Finish the end behavior, and then again, look up on the board, and I'll answer any questions that students may have afterwards. Ready? Begin. So I should hear you talking with your partner about this? Quick hands raised if you'd like me to describe this one. Quick hands raised. Hand up. Anybody? Okay, here we go. So for this problem, this says as I go to the far left of the x's, far left, what's happening way over here? Is it headed up or is it headed down? It's headed down. As I go to the far right, what's happening? It's headed down. Remember, at this point, our parabolas will both go up or they will both go down. Okay, we're going to move on to mini lesson number 4. Mini lesson number 4 is actually something you learned, some of you in 7th grade, others in 8th grade, and I'm pretty sure it was not the first time you saw it in 9th grade. So please write intercepts above mini lesson number 4. So for these two problems, we are going to identify the x and the y intercepts without using a calculator. Quick review. Parabolas that open up and open down. How many y-intercepts do they have? Always 1. How many x-intercepts do they have? 0, 1, or 2. 0, 1, or 2. Okay, so when you find a y-intercept, we always set x equal to 0 every single time. And this is the easy stuff. So I get to substitute in a 0 and substitute in a 0. And I'm going to just change this to a y because f of x is the same as y. And I have 0 squared minus 5 times 0 plus 3. So when x is 0, y is 3. Let's write it as an ordered pair. Anybody have a great memory? When are you first exposed to the quadratic formula? Is it 8th grade? Yes, for most of you? Okay, or definitely by 9th grade, right? This is something you have to have memorized by tomorrow. They assume you already know this. This will always help you to identify the x-intercepts. So we're going to do it without a calculator. Remember that in this case, a is 1 in this problem, b is negative 5, and c is positive 3. And I'll use a pen so it maybe shows up a little bit better here. So I'm going to substitute in the values. Now here's where I saw a lot of mistakes earlier today. See where it says negative b? That means the opposite sign of b. So b is already negative 5. When I substitute in, it becomes a positive 5. And I put a plus or minus. I'm going to square b. So negative 5 squared, negative 5 times negative 5 is 25. A is 1, c is 3, and put that all over 2 times a. 2 times 1 is 2. Okay, so now I'm going to do this work. I'm going to multiply this section over here. Negative 4 times 1 times 3 is an answer of negative 12. And now I ask myself, 25 minus 12 is 13. Can 13 be reduced? Is there a perfect square other than 1 that divides nicely into 13? No, there's not. If you're like, what is perfect squares? 1, 4, 9, 16, 25. None of those nicely divide into 13 other than 1, which doesn't reduce it. So this is my answer. How do I write the x-intercepts? These are two x values, so I'm going to write very small up here. Here's one answer. 5 plus radical 13 over 2, comma 0, and 5 minus radical 13 over 2, comma 0. Moving on to the second problem. So we're going to start by finding what is the y-intercept here. So again, when I find the y-intercept, x is always equal to 0. Well, we can kind of cheat here. 0 squared is 0. Negative 3 times 0 is 0. So I have 0, 0, minus 9, which gives you an answer of y equals negative 9. The y-intercept is 0, negative 9. X-intercept, in this case, A is 1, B is negative 3, and C is negative 9. Again, we start with negative B, so opposite sign of B would make this a positive 3, plus or minus. Now I want to square the B, so negative 3 times negative 3 is 9, minus 4 times A times C, all divided by 2 times A. 2 times 1 is 2. This area within here, okay, we want to come up with an answer for this, our discriminant. Negative 4 times 1 times negative 9. Negative 4 times 1 times negative 9 is positive 36. And 9 and positive 36 is 45. At this stage in the game, you can't leave your final answer with a square root of 45, and the reason is because we can break this down. So the square root of 45 has a perfect square of 9 that divides into it, because 9 times 5 is 45. So I'm going to rewrite this as x equals 3 plus or minus, and 9 and square root of 5 turns into 3 square roots of 5 over 2, because we know the square root of 9 is 3, and the square root of 5 is irrational. So how do we write our ordered pairs? 3 plus 3 square roots of 5 over 2, and 3 minus 3 square roots of 5 over 2.